Okay, and I wanted to work this example of 7.2 confidence interval of population mean again with the calculator. Um, so we have the sheet here titled one sample t for mean because we're using a t distribution. All we need to do is put in our sample mean. So in this problem, our sample mean was 98.6. I'm sorry, 98.1 was our sample mean. Our standard deviation was 0.56 for the sample. Our sample size was 103. And we want a 99% confidence interval. So we put in 0.99 and the formula works for us. And we are given a lower confidence of 97.96 and an upper confidence of 98.24, just as we got on the other video. The other thing in 7.2 that is important, again, is the sample size if you are going to try to estimate the population mean with sample means. And you do need to have a z-score, a critical number from a normal model, and you do also need an estimate of the population standard deviation. Now we know we use the t-distribution because that sample standard deviation and that population standard deviation is hardly ever known. But we do have the range rule of thumb to estimate the population standard deviation. That is, take your range and divide by 4. So here we have a problem to find the sample size for a study. It says, assume that all grade point averages are standardized on a scale between 0 and 5. How many grade point averages must be obtained so that the sample mean is within 0.011 of the population mean? So here is our margin of error, and we want a 99% confidence interval. Okay, so by the range rule of thumb, we're going to estimate the population standard deviation of GPAs as 5 minus 0, because that's our range, divide by 4. 1.25 is our estimated population standard deviation. If we want a 99% confidence interval, then our alpha is going to be 1 minus 0.99 or 0.01, and alpha over 2 is going to be 0.01 divided by 2, 0.005. And for our normal critical number, we're going to use norm.inverse. We are going to use 1 minus alpha over 2, a mean of 0 and a standard deviation of 1. So there's our critical number for 99%. So our margin of error was given to us. We want to be within 0.011 of the population, and we want to find we don't know our sample size, but we're going to find it. So the formula for sample size is not the same as the sample size formula we saw before. So let's find this sample size using this formula here. We're going to take our critical number, let's do a double parentheses. We'll take our critical number, we'll multiply by our estimated sigma, and we'll divide that by the margin of error, and then we'll square the whole thing. And let's see what our sample size is. So we have 85,677.9, and of course we always want to round these up. So let's round it up to 85,678. Now, note that the sample size does not depend on the population size, and also note that sample sizes of over 10,000 really are not practical for a survey, and this is well over 10,000. So we would have to say that this is not a practical sample size, and we might have to rethink our strategy.